shape of our molecule or molecules. These are what molecular compounds actually look like. And so what VSEPR structures do is they're going to take our 2D Lewis structures and then turn them into actual 3D structures or molecular geometry structures. What VSEPR actually stands for, VSEPR, is valence shell electron pair repulsion. And what that means is just simply electron pairs are going to be pushing each other away until they are as far away from each other as possible. And that means electron pairs in a bond and also just lone electron pairs. And so what happens is this is actually what results in our 3D shapes of molecules. A couple things real quick before we show you these 5 examples is a couple little notation things about how to draw or indicate the shape of structures. If you see a solid line, black line or whatever, that's going to be a bond that's in the plane of the paper. Okay, because again we're going from 2D structures to 3D, and so actual molecules are 3D. So what we have next right here is going to be something coming out of the paper. Okay, so it looks like a black little triangle. And then if it's going back into the paper, it's going to have these dashed lines like this. So here we go. So the way we're going to tell and start with here is the number of terminal atoms. So the geometry depends on the number of terminal atoms. If you have 2, it can either be linear like this, so you'd have a central atom in the middle and then 2 outer terminal atoms, and it would be linear. And if we'd actually look at a 3D image, it would look something like this. So this would be linear structure. If it has a couple lone pairs, 1 lone pair or 2 lone pairs, it's going to be a bent shape. So these lone pairs of electrons are actually going to be pushing the electrons in this bond here, and these over here are going to be pushing electrons in this bond here, giving it this bent shape. Looks like this. And so here's our lone electron pairs, and again they're pushing down on these electrons in these bonds. If we have 3 terminal atoms, we can either have something called planar or pyramidal. And so planar is called planar because again everything's in the same plane. So we don't see any triangles or dashed lines here. We just have strong solid lines like this. So what this one might look like is, we're going to scroll down, like this right here. Okay, so it's all in the same plane. And again, electrons in each one of these bonds are again pushing each other as far away as they can be. And so every angle here is going to be the exact same. The other example of molecular geometry with 3 terminal atoms is going to be pyramidal. Okay, and this one's a little bit tricky because now we're going to start to use our other notation. So this one has a lone pair of electrons up here, and the shape of this one is it actually looks like a pyramid. And so the way we draw this is we're going to have one bond that's in the plane of the paper right here, and that'll be a strong black line. We'll have one coming out of the paper because it's a 3D structure, and this will be that triangle shape. And then if it's going back into the paper, then it's that dashed line. And again, there's just a lone pair of electrons on top, which is what's pushing these electrons in these bonds down. So instead of having this shape over here where they're exactly in the same plane, this is pyramidal. It makes a little pyramid because these electrons here are pushing down. And then the final one is going to be tetrahedral. Okay, and this is where we have 4 terminal atoms. So tetra means 4, right? That's a prefix for 4. And this one in 3D is going to look like this. So in this one we've got 2 bonds that are going to be in the same plane as the paper when we draw them out. Just right here. One's going to be coming forward. That's going to be our little triangle coming forward. And then the other one is going to be going back into the paper. And again, all these electrons in each one of these bonds are trying to be as far away from each other as possible. And so it creates this shape right here, which is a tetrahedral. So again, VSEPR structures are what takes our 2D Lewis structures and puts them into a 3D molecular geometry.